Hello, everybody. Good morning to you and good afternoon, wherever you are. Today we're going to be talking about MyGNUHealth. It's a Libre project for a personal health record, and it's part of the GNU Health ecosystem. Just to go through the agenda very quickly, we'll go through the history of the project, and then we'll talk about the components, and finally we'll dive into the application itself, the mobile application, and this is a bit more technical than others, but not too techy anyway. So I think that everybody would be able to follow it. And hopefully, I think that we have until 9:15, 9:20. So we get some time for the questions if there are any. Just a little bit about myself, my background, academic background and professional background. I'm a computer scientist and a medical doctor, and basically I've been specialized in genomics and medical genetics. But the things that move me the most are social medicine, animal rights. You might hear my dogs between the talk calling me for a walk, and of course Libre software. And it's a great combination to work in the three of them in these sort of projects. So this picture was one of the very first one that we took in Argentina. This is 2006, and it was the initial or the kickoff of the GNU Health project. We were working initially in rural areas schools, and then I felt that these kids needed more than just technology, and that's where the primary care concepts and the public health and all these socioeconomic determinants of health came into light. And a couple of years later, GNU Health was a reality. So GNU Health is a project from GNU Solidario. GNU Solidario is an NGO that works on social medicine, and we have a global, we're a small NGO, but we work globally. We have projects in all continents today, and it's also a GNU official project since 2011. These are just some very quick summary of different projects around the world, from Laos, Jamaica, Argentina, Mexico, India. And we work with multilateral organizations like the United Nations University or the World Health Organization. So what's taking us today, it's again MyGNUHealth, and as I said at the beginning, it's part of a larger project called GNU Health. These are some of the components, technical components that we use in our project. All of them, of course, are Libre software, and from operating systems as OpenSUSE or FreeBSD, database. We use different, like PostgreSQL or TinyDB, Python as a main programming language, Qt, Triton, Flask, and the documentation today is on Wikibooks. We use Vue.js for the Federation portal and GNU-PG mainly for signing documents and encrypt documents. So GNU Health, as I said, it's an ecosystem. It's a set of programs that do different tasks. Okay, so we have health hospital information management system. We have a laboratory. We have, we'll be talking today, personal health record application. We also work on the areas of precision medicine and bioinformatics and genomics. And also we have the embedded solutions, so you can run GNU Health on single board devices like Raspberry Pi or Caras or Olimex. So from all of those components, we have this screenshot is set of different scenarios within the hospital management information system component or node. I call them nodes. So you see that you can do diagnostic imaging, have your agenda, work on histopathology. You have charts for epidemiology or growth charts in pediatrics and so on. And basically, you can run your health institution, your hospital, your primary care center, or your private doctor office or laboratory. So now let's get into the details, or more than details, an introduction of MyGNUHealth and why did we create this application? Why are we creating this application? The main idea behind MyGNUHealth is putting the person, the citizen, the patient on the driver's seat, right? I feel like as a physician, most of the time, the people or the patients are more of like passive actors, you know, and they pretty much are supposed to take the orders or the recipes or whatever the health professionals tell them, and that's a mistake. We have to empower the person to be an active member of the system of health. So within this GNU Health ecosystem, MyGNUHealth uses this technology that you're seeing here, okay? So as in many other components, Python is the main programming language. We use, again, GNU-PG for privacy and for signing documents. In this case, we are using TinyDB as a document-oriented database, because remember, this is now a one-to-one relationship between the person and your database. This database is not a multi-user DB. This is your DB. It's going to be on your desktop or on your mobile device with your only data. Then we'll see Kirigami, that makes it convergent, Matplotlib for charts, and Qt for all the framework of the graphical interface. We use Plasma Mobile. So Python 3 is the main language, as I just said, and most of these components, you can find them today at the Python package index, PB. And again, as many others, okay, so you can find Thalamus, or you can find all this stuff related to bioinformatics at PyPy2. So we are using Qt for all the graphical interface, by using the PySide package. Okay, so basically it's the Qt for Python or PySide 2 package that allow us to interact with all the Qt classes already existing, and it's rolling out really well. Now, one of the good things about Qt and KDE framework is this component called Kirigami that allow us to make MyGNUHealth convergent, and that means that it will adapt to different scenarios. So if you are running MyGNUHealth at your desktop computer, you will have your widgets and your UI adapted to that desktop computer. Now, with the same code, you will be able to run it on a mobile device, whether it's your tablet or whether it's your mobile phone. So here is a very short example of MyGNUHealth PY, the very first or main program, and you can see in this slide how you actually import those modules. So you have PySide2, Qt widgets, Qt core, and Qt QML. We use QML for the design, and the logic is always on the Python side. It's a nice way to divide UI from the logic, and it's pure Python 3 code. So this is an example on how it will actually be seen on the Plasma desktop. You have two screenshots from different contexts, right? And you will be able now to see in the next slide how would it actually look on the mobile devices. So this is actually a picture, a photo that I took from the PinePhone, and again, you know, I didn't have to change a single line of code thanks to Kirigami framework, right? If you see this slide, you will see this little icon here, the typical X from the X Windows system, right? And of course you have the Windows frame and so on. And then when it comes to the PinePhone, all of those frames and icons disappear for the sake of expanding, right? And optimizing the viewing experience and the layout on smaller screens, and it works really, really nice. Now, a few words about the storage. So one of the things that we need to do is to be able, of course, to storage all this data. If we want to have a chart on my blood pressure or on my blood glucose levels, I need to be able to retrieve it from somewhere. And of course, there are many really good databases engines, both for regular computers as for smaller devices. But I also wanted something that it was going to give facilities to the end user in terms of searching for documents and be able to make a single backup and take it from your desktop to your mobile and vice versa and so on. And that's where I found TinyDB. TinyDB, it's a document-oriented database. It's basically a nice way to represent JSON and to store JSON objects. And and it's of course platform independent. That means that if I take that dump from my desktop, I'll just take the file and I can just put it on the tablet or on my mobile device, and it will just work fine. And that makes it very portable, and so far so good. It's a really nice document-oriented database that for this case, where we don't have much of concurrency at all, it's basically a single-use database. It's working beautifully. So now we've talked about pretty much running MyGNUHealth, my personal health record, on my devices, right? Whether it's my laptop or my mobile device and so on. But that is good, of course, that is great, but we need to go one step further. And that means we need to integrate this data in the system of health. So my health professional can see all those results without me having to go to the health institution. And especially now with this pandemic context, that comes very handy, because then you know, you can have pretty much a daily, all your daily activities being monitored by your health professional, and you can take action, or she or he can take action depending on the values that you are providing. And that's where the GNU Health Federation comes into place, right? If you see this slide, you will see that it has pretty much three sections, right? You have a left side with three icons. Then in the middle, you have Thalamus. And then in the right side, you have the GNU Health Information System. Well, the components that you see on the left-hand side, those are the nodes that make up the GNU Health Federation. So one of the nodes can perfectly be a hospital, running the hospital management information system node from, GNU Health. The other can be a laboratory, and the other can very well be MyGNUHealth, right? So this could be MyGNUHealth application. What happens is you are going to have the possibility of setting up MyGNUHealth and saying, well, I want to be part of the system of health, right? So you have a network settings that we'll see a little bit afterwards, where you can actually say, well, this is where the Thalamus server it's located, and I want to provide my credentials, so whenever I enter my data, that can actually sync or be in sync with the with this very large database that we'll have on the public health system, for example, right? So the Thalamus is pretty much a message and authentication server that it will allow you to go and put data and retrieve data depending on your access rights, right? So basically you have an ACL that says, well, you can actually, providing that you have logged in correctly, and you can do this and this and this on this and that resources, right? And the Thalamus it's pretty much a Flask application, right? So this is just to show you how you can couple with the GNU Health Federation from your own MyGNUHealth application, right? So in this case, you would go to network settings, right? And then you establish by default the SSL HTTPS protocol. Then you put where is that Thalamus servers. In this case, we have in Germany, this is the Federation GNUHealth.org. This is a public server that we have set up so everybody can test their nodes and play around with the system. You put the port, and then you have your unique federation account and your password. So what is the federation account? Well, this is something that we actually introduced this concept some years ago already. And what we need or what we want to achieve with this is that no matter where you are in your province or in your region or in your country, your health data is going to be up to date. So if you are in health center A today and you go to health center B tomorrow in another province, whoever is going to see your clinical history is going to be updated. He or she doesn't have to start from zero to get all the data from you. It will be already there. And that is a huge advantage because, believe it or not, we are still in many places in the world and in many places within Europe where different provinces have their own local database and they don't talk to each other. So if you go from Madrid to Barcelona, you're going to start from scratch with your medical history and clinical history. And when that is within the public health system, where pretty much we have 7 minutes per patient, that takes precious time out of your visit. So once you have this set up, all the data that you put and you wish to put, because again, if we go here, if we go back here 1 second, you see this sync Boolean here field, basically saying, I want to be part of the system of health. Okay, and if you don't put the sync, and if of course if you don't fill in this data, you have your data only for you, which is perfectly fine too. So this is again a bit of a summary of what I just said about the benefits of having every person as a node. So until now, the nodes were pretty much health institutions. Okay, so you have many health institutions across your country, and yes, today we have the ability with the GNU Health Hospital Management Information System to sync all your patients' evaluation, lab, clinical diagnostic imaging, and so on. But we didn't have a tool that would make the person an active actor, right, in the health system. And that's where MyGNUHealth comes into play. And that's where you now as a citizen are a single node. Now, all of this is really great. But if we look at it not only on the COVID pandemic, which of course will make a huge difference, and it's already making it in some countries, not at MyGNUHealth, but at the Hospital Management Information System. Think about what we can do in rare diseases, in cancer research, in autoimmune conditions. There are so many things that we can do in the fields of precision medicine with the GNU Health Federation that is incredible. And you can only do this if you have this sort of federated database. and this federated distribution. We work with the UniProt databases and the UniProt team, and we have thousands of natural variants and proteins, or basically mutations in genes that today we are uncertain of what is the clinical significance of many of those mutations. So some of them we know, and yes, we can say, well, this is non-pathological, or yes, this is a clearly pathologic mutation, so it has a very important clinical significance. But many of them, we just don't know what can happen to us if we carry that mutation with us. And by having this sort of infrastructure, you can find, or it will help us finding a correlation between your genotype and your phenotype. So what are your genes, and what is the expressions of those genes? And for those, especially for those mutations where we still, or natural variants that we still don't know what is the clinical significance. And this would be really a breakthrough. And we are pushing to have GNU Health and MyGNUHealth in different countries around the world. Of course, we already have that. But now that we are in Europe, we want the European community to embrace MyGNUHealth and GNU Health Federation to tackle these genetic diseases and of course, cancer research. And in Argentina, for example, the National Agency for Research has chosen MyGNUHealth to work on as an observatory for the COVID pandemic in the Entre Rios province. And again, this possibility, or this ability of the MyGNUHealth, of the GNU Health Federation to be able to do real-time charting, real-time epidemiology reports, in many cases will stop an outbreak from becoming an epidemic, right? And it would be great to have had this in the early times of the COVID. But anyways, it's there, and it's available for any public health system in the world that wants to use it. And we are not just talking about infectious diseases. There are so many other diseases that are not contagious. So we are talking about diabetes. We are talking about domestic violence that are as important as contagious diseases, and we need to tackle them in the same matter. So just wrapping up, some of the things that we are doing today and some of the things that we need to be done and need to be where we need to put the focus. Again, as I said, currently we have the mercurial repository at Savannah, GNU. And the documentation is on Wikibooks. We are supposed to be releasing a beta version by the end of the year. And things that we would like to work on, of course, packaging, localizations. We've done a pretty good job on localization with the hospital management information system, but today MyGNUHealth is in English only, so we'll have to work a bit on that. So no matter where you are, you will have it on your own language. Of course, strengthen privacy and security, making sure that everything is in place. The difference between MyGNUHealth and the hospital management information system node is that MyGNUHealth is to be run by people that not necessarily is technical. So everything should be very, very simple to use. And as a matter of fact, MyGNUHealth should be already installed in, for example, the PinePhone. So whenever you get the PinePhone, you will have MyGNUHealth in place. That would be wonderful. And if not, it should be simple to just download as a regular package. Oh, by the way, we, or at least I, work only on Libre operating systems and Libre devices. That's why I have chosen the PinePhone as the first mobile device to install or to develop MyGNUHealth in. I don't work with Android. I don't work with iOS. I don't work with Microsoft Windows. Those are non-Libre environments, and I don't really want to spend my time on those. If anybody wants to port MyGNUHealth to any of those operating systems, you are most welcome. But I think that it's not part of the GNU Health philosophy. GNU Health is a social project that that uses technology, but mainly is a social project. And I think that anything that is non-Libre goes against our philosophy of universal healthcare, and it's putting some sort of bars in front of people to reach that universality and that freedom in healthcare. That's why, again, I only work with Libre operating system and environments. As I said a couple of slides before, we have a testbed. We have a community public server in Munich where anybody can just log in and play around with it. We have a Thalamus installed there, and we also have the hospital management information system. So you can log on, create a patient, check the the lab test, imaging, and also play with this concept of the federation. So you can install your own node and start syncing information back and forth and so on. So that should be running 24/7, and it's been there for quite a bit now. And next week, right by this time, we will start the GNU HealthCon 2020. It will be also online as the one that we are doing today at the Linux Application Summit. And you are most welcome to participate on it and to get in touch with the community, see all the guys from Qt and from the Plasma Mobile and from the OpenSUSE and so on that will be there hanging out with us and giving out a lot of cool information that definitely will be in the next upcoming GNU Health and MyGNUHealth releases. So remember, this will be next Friday, November 20 and November 21st, Friday and Saturday. And you are most welcome to register right there at www.gnuhealth.org. And that pretty much makes it for today. this is just some information I will leave it there for you. So if you want to get in touch with us, we'll be very happy to listen to your questions and comments, which of course are very valuable, because at the end of the day, what you see today, it's a 12-year project and 12 years of feedback from the community, which have given us the success that has GNU Health today. So yeah, we're going to have like 8 minutes if there are any questions.
Yeah. Thank you, Luis. We do have some questions. If you would like, I can say them for you.
Great. Yes, please. Alison.
We have a few minutes, so let's get started. The first question is, what challenges does this app pose on terms of privacy?
Yeah, well, actually, one of the reasons that we create MyGNUHealth is actually to empower the person and make sure that you are in charge of your own privacy. And that's why we don't use any operating system or any device that is non-free, because you are going to have the source code, you are going to have the possibility of encrypting your data, and you are going to pretty much be in charge of your own data. And if you want to be part of the GNU Health Federation, you might be very well welcome. But from start to end, you are in charge of your own privacy. That's what it makes it different from other personal health records. And that's why actually one of the main reasons we created MyGNUHealth.
Okay. The next question we have is, what are the open hardware devices you are currently looking at?
So we have, we basically have the PinePhone on mobile devices, but then we have the CADAs, and we have Olimex as single board devices. And we also have images for the Raspberry Pi 3 and 4. So those would be the open hardware technology. I would say that from all of those, CADAs and especially Olimex is really, really from A to Z open hardware. It's a great, great device.
All right, the next question we have is regarding privacy. Who has access to data on Federation and how?
That the access to the data on the Federation, it's ruled by the access control list that you have on your Federation ID that I talked previously. So if you are a citizen, you will have a citizen profile. If you are a health professional, you have a health professional profile. And if you are in the Ministry of Health, you will have a Ministry of Health for epidemiology and whatever profile. So depending on your profile, you will have different access control requirements to different resources.
All right, Luis, this is the last question we have. It is, how is duplicate data handled?
You shouldn't have any duplicated data because every single message has its own UUID. It's unique ID. So you can have 2 different records with the same value, but those would be different IDs by itself. So every node has its own ID, and every message within the node has its own unique ID. So it's pretty much impossible to have duplicate data.